Hey everyone, nice to meet you all. It's like surprisingly huge event. I'm very nervous. And let's go. As you can see, my name is Slava or Svyat, and it's going to be a bit of an entertaining talk. To share some context about the talk, I need to explain last 3 months of my history in very short. Back then, in beginning of July, I still was working in Google Cloud in virtual network data plane team and moving packets around in C++. And it was quite nice time. Late in the end of July, beginning of August, I get lots of experience in packing boxes and moving to UK. So landed here. And my travel at Google concluded. And since then, I'm experiencing C++ in the wild. And experience of C++ in the wild and like C++ is in a big company, very, very contrasting. And this contrast bring me to the idea of this talk. And the talk is C++ which just works or doesn't work at all. So yeah, as you can guess, the name of the talk is half joke, half sarcastic. But to deeply understand what this means, C++ which just work or doesn't work at all, let's formulate what a person like me may want from a piece of C++ code. So what means person like me? Now I'm a member of technical staff and Perplexity AI, and I'm working about core search engine in Perplexity AI. We're doing C++ stuff, and like it's classical information retrieval. And when I meet a C++ thingy, probably it's a program, and the first thing I want to do with it, it's usually I want to run it. It's like simple as that. If I run it and I like it, or if by chance this piece of C++ code not a program but a library, I want to link it or compile against it. Okay, suppose I succeed in one of two. There is a good chance that it's not satisfying my needs, or I need to understand something better. In this case, I want research about how it works inside. Okay, suppose I mostly formalize myself with the program. Now I want to deploy it. But deploying C++ or like deploying whatever is a huge topic. And we're not going to talk about it. So it's like a topic for dedicated conference. Suppose I succeeded some way. After that, maybe I want to patch and test it. So I succeed in running program and using it. And now I'm happy to try to modify it for my needs and understand that I modified it right. Okay. So this is a set of needs. And now let's travel a bit in time, 3 months back, and try to get feeling how it was for me 3 months back then. Let's go. To adjust my pace, wave me if you ever used Bazel or Blaze. Okay, so surprisingly small fraction in the crowd given the DeepMind in the next building. So I'm not going to rush. Let's go. So back then I was experiencing a huge monorepo which is working on essentially on Bazel. And if you open the Bazel documentation, you will get a good feeling of what was going on. So, and to run a program, first of all, I need to find the code in the code base, find the target which I want to run, and do that. Blaze run something. Bazel run something. And it, under the hood, will compile it for me and run it for me. Like, as simple as that. Okay. Suppose now I want to use part of it or link against something. I was writing a description of my program, which starts as CC binary, which is like Bazel piece of configuration saying that, okay, I'm describing that this build target is a C++ binary. It has a name. So you saw it in the end after semicolon, awesome binary. This is it, this name. And after that, I'm saying that my binary contains this source file. Essentially, this source file probably contains main and some stuff around. And after that, the purpose of this slide, dependencies. This is the stuff I'm linking against. So there is my awesome program, awesome lib, which I can describe in similar manner, which is inside of the repo, and the interesting stuff, third-party something. Here's the exciting stuff. Suppose I would need a library which is an open source, something which is not written inside of the main repo. What would I do? I will go to the third-party folder and try to find it. With a huge probability, it's probably there. And suppose I hit those like 1% when it's not there. Okay, then I'm talking with the right people, understand whether it's actually worth it. I never did it, so I'm just guessing. And if we agree that, yeah, this is something which is actually worth bringing, I'm creating a bug, or I'm helping, or like I'm just vendoring it. It would take like a few weeks or some reasonable amount of time. And once it's vendored, I go to the third-party folder, and my library is there because I forcefully push it to there. Okay, and this vendoring part is the only hard part. Okay, now let's move on. I'm succeed linking against something and using part of the code. Let's test it. Test is extremely simple. So I'm writing that this is a test in my Bazel repo. This is the name of the test. This is the source code of the test, and it has some dependencies. Source code of the test, probably this is, any C++ testing framework which you would use in your project. Cool. Now to patch it, it's as simple as opening the editor, and after that do blaze run. Bazel run. And it felt like ideal world to some extent. So suppose I'm a person who is liking to write a C++ code. I had to make zero effort to add a new line of code. And here I'm making an assumption that in mostly any huge company, in any huge repository, it felt mostly like it. And now let's back to the present time. Now, month and something, maybe 2 months, I'm heavily experienced C++ in the wild when, okay, I have my GitHub repository, which I'm writing the code. I'm writing a lot of the code. I'm enjoying it. But eventually, the following moment comes. You can't write everything on your own. C++ standard library doesn't have like all batteries which you may need. So at some point in the meeting or in your mind coming the idea, okay, here's an awesome GitHub project which I would like to use for my needs. And now let's try to make an exercise what we need to do to go through all same steps in this setup. So I have a GitHub project which I want to run. Okay, it became interesting. Usually when I experience something like that and I need to run something fastly, I'm going to my package manager or Linux distro which I'm using and trying to find it. And sometimes I'm succeeding. But For sure, it's working not always, only for popular project, only if I'm not using something weird. I don't know, some old Alma Linux, which is like real life example. Okay, suppose I'm failing with Linux distro. Maybe I'm lucky enough and the project which I'm planning to use publishing binary releases. Okay, in this case I'm facing fighting with dependencies and with huge probability if I'm working on ARM or something a bit weird, like not the most standard stuff, there is no binary release. And after that, you are going to the adventure of compiling external project. And it easily became an adventure for a few days. Okay, so it's stopped being so easy and fun. Now let's think about how to research what is going on inside. Okay, I succeed to run it. Now I can do GDB, perf, trace, whatever. Unless I don't have debug symbols. Okay, and crafting debug symbols for myself is a huge adventure. So again, either I'm going and looking for develop package which will provide me debug symbols from the Linux distro. Either I'm trying to build with debug symbols. Either I don't know. It's again a quest. Okay, now interesting stuff comes. Suppose I succeed in this and I want to patch and test it. First of all, patching is as complex as compilation. Suppose you know what you want to modify in the project. Unless you can't compile, you can't send a PR, or you can't use your patch. And many of projects I met on the way has much more dependencies for tests than for the actually building your binary. And as a result, okay, you patched it, and you have no ideas, no way to actually understand how good your patch, how it's actually, that's not breaking anything. Okay, and now the most complicated stuff comes. Suppose we was talking not about the binary, which is provided you in the GitHub repo. And it's a library which you want to use. And stuff here became crazy. Overall, you are probably cursed. So, but you can try a few reasonable stuff. You can try to go to the develop packages in your distro, which is even more rare than packages delivering you a binary. Then the most common stuff is go to with Git submodules when you can when you're just creating a submodule with external repo and after that trying to compile with it. But it's again an adventure because first of all you need your build system to build at least somehow has at least some sort of interoperating, have some interop between them. And the most painful stuff, you need the project you want to compile to be at least somehow compilable with your flags. The most common way, you have a quite good code style and quality of the code, and like you are fighting against compile warnings. You are bringing some submodule and everything blows up. Okay, there is a painkiller to some extent. If you want to use something small enough, maybe it's header-only library. But this way will make your compilation incredibly slow, and you can't pack everything into the header-only libraries. And on the dessert, you can try to use Conan, Nugget, and C++ packet managers, which has reasonable chances to work, but there is a big problem that they're not really popular and reasonable chances that you won't find it. And overall, it feels incredibly hard. So like the same list of stuff you want to do is so complicated, and the amount of problems you need to solve per one line of code is, a few orders of magnitude larger. Okay, and this was somewhere around the time I start thinking about the talk. Okay, why so? And what we can do to reduce this pain. So like suppose I'm planning to start a new open source project or like just publish something in the GitHub with the hope that someone will try to use it. What can I do to reduce the pain? To answer this question, let's think why it was so easy in the setup 3 months ago. What do you have in a big corporation? Remember the slide about vent drain? And it gives you very convenient thing. You don't have external dependencies. All dependencies you have internal to your build system, they kind of belong to you. You have a common build config language. So in this case, it was Bazel. In other corporation, it can be something different. Even if you have one huge mono repo with CMake, this is also okay. And your environment is well known. You know the set of machines on which your code is going to write. You know the set of CPU architectures. You know which distribution of Linux distribution or macOS version on the laptops of your employees. And this allows you to make things which works. You reduce the surface of the problems you need to address. You know that you need to work on 1, 2, 3, and you just test it in these environments, and it just works. Okay. And now let's try to think what we can get from it and bring it to like standard wild C++ in the wild, to your GitHub project essentially. The most interesting stuff is external dependencies. Okay, what can we do about external dependencies in C++? So I think a lot about this slide, and so the answer is, to some extent, you can struggle. But good news that you are going to struggle in a good company. C++ Foundation every year does survey for C++ developers about what tool they use, how they compile, which features of the language is allowed, and there is a good question: how do you manage your first-party and third-party dependencies? And let's look into this slide. Okay, is it readable? Okay, anyone? No, not readable. Okay, cool. Let me read it for you. The first one is, okay, and the pointer is also not. Okay, the first one is, the library source code is part of my build. Okay, welcome Git submodules and all pain which it would bring to your project. The second one, I'll compile the libraries separately and using their instruction. So essentially, you are checkouting your library, after that doing build, installed it into your system, and after that using it like shared library or something like that. Okay, system packet managers. Cool. And only after that, in 22%, the first option which meant to not bring pain comes, and this is Conan. And after that, we have small options. Oh, like options with even smaller percentage. And it says us that actually, when I was struggling, I wasn't doing anything wrong. It's kind of meant to be. And I get feeling that once I'm facing a problem of C++ dependencies, it's like I'm trying to prove a theorem and I'm facing P equal to NP problem. So yeah, okay, not solvable. Yeah, question?
What are those percentages? Because they add up to way more than 100.
Again?
What are those percentages?
Sure. The survey working like that. There is a question, and after that, please choose everything you use. And so after that, 60% saying, I have at least one library which is part of my code base. So yeah, it shouldn't sum up to 100. Okay, as we already interrupted, any more questions up until now? Okay, cool. Now let's think about build languages. and build systems. I did the same exercise. And surprisingly, it brings some, I know, joyful result to some extent. Mostly 85% of developers saying that they're using CMake, which makes CMake kind of a thing which you would expect from any standard open source repo. And this is awesome. For me, actually, it doesn't matter which language to use. The only stuff I really need is interpretability and something to talk on. And seems like CMake is an answer. And now let's think about environment. So what is the purpose of the environment? You want to reduce amount of, no, not reduce amount of problems. You want to reduce the surface you need to test. If you have a well-known set of operating systems, etc., it's with much lesser probability going to break in a weird way which you have never seen. And surprisingly, there is a good answer here. The best experience I ever had once I tried to patch or develop some open source component was a Docker. So if a project has a Docker image, it doesn't matter what is inside. It could be Nix OS, it could be usual Ubuntu, or it could be something as weird as Rocky Linux or CentOS. It doesn't matter for me. I can get used to it. The main benefit that I know that stuff inside of it is going to work, and I know that developers of the projects is actually using this image to develop it. And it brings me to the funny idea that, okay, external dependencies is not solvable problem. And in any other language except C++, you would expect such stuff to be solved, like cargo install, pip install, poetry install, or any package manager install, which will bring you all dependencies which work for you to your machine. And these dependencies kind of tested in the environment where package manager works. Oh, we can't do this in C++. That's why we have to package the world. So if you want to package a C++ program, you're taking the world where it exists, which is an operation system. This is that you are packing the operation system and deliver to the hands of the developer. And it's working quite nicely. The only problem, which survey confirms, that you can't pack library in this way. So if you want to use part of your program, you can't pack the whole world. And it's really painful. Okay. The main messages of the talk in one slide. As we saw, C++ dev experience can be nice, but it's kind of hard to achieve. We saw the problems, and solving them the same way as big corporations do is expensive, and probably we can't do this. But yeah, we will have to face that external dependencies problem is open. And so I'm not so young already, but still relatively young. But still, I developing in C++ for around 10 years. And I can't see that the problem became better. There is some hope that Conan will rise or Nugget will rise and we will get awesome working external dependencies, but seems like no. CMake is the de facto industry standard. And here the first actionable thing from the talk. Suppose you are building your new project. You can use whatever build system you want, but please help the community and provide CMake lists for anyone for any other project which is using CMake being able to use you. And the last one, please provide development containers. Without this, life is incredibly hard, because you even just to start touching your project, you are facing quests which can last in days. And thank you. This was Slava, which was facing C++ in the wild. Any questions? Or I don't know. Ideal question would be, Slava, you don't know anything. The problem is already solved, just use X. And I don't know, beer is on me in this case. Yeah?
No. So like you mentioned that, it's solved, and then you mentioned that you have no experience doing that. I've done that. I've brought external projects for big build systems for both Chromium and at Meta they use Buck. It's the same thing. There is, except because you don't use CMake, you have to figure out how in the world you're gonna build your thing. And that basically means writing the whatever equivalent of CMake lists for the whole project yourself. So no, and the big projects didn't help you here. Conan is pretty good.
No, wait, but in big corporation you have a talented developer which will do it for you and which is going to receive reasonable amount of money for it. And in the end, you as a developer which is just using something is happy.
Unless you need to update.
Unless you what?
Unless you need to update your dependency.
Ah, yeah, for sure. But this is kind of vendoring again. Cool.
No more questions? Okay, thank you very much.